Good evening, everyone. Thank you for staying past normal working hours for a quick talk. I want to caution everyone on the accuracy of taking advice from a full professor on how you too can become a full professor. I would not have my career in biostatistics as well if I weren't cognizant of something called survivor bias, which is to say that just because what worked for me to make it through the maelstrom to become a full professor does not mean that saying whatever comes to mind or screaming at your computer, for example, is in any way conducive to becoming a full professor. Each of us, I'm afraid, must find his or her own path, and I'm happy to talk with you on how to make your path work. But that said, I would like to take this evening the opportunity to talk a little bit about how South Africa can solve a problem that is holding back biomedical research in this country. And I think that this question on screen might make it more present to everyone. How does South Africa train the next generation of bioinformatics PhDs? This is, after all, the question that convinced the Medical Research Council that they needed to pitch in a bunch of money to bring me here. And it's a question that doesn't have easy answers, but I'm hopeful that we can walk through these questions together. I also must note that the asterisk on this slide points to the need not just for talent in bioinformatics, but also in biostatistics. These are both specialties that are in short supply, not just in South Africa, but will be necessary to us achieving our goals. And of course, I hope you'll indulge me if I tell a few tales from my own life that I think can illustrate different points along the way. One of the questions that I most frequently hear when people don't recognize my accent is where I'm from. I'm tempted to say that I'm from Missouri, but sadly, a lot of people in South Africa don't know where to find Missouri on the map. So I've helpfully labeled it number 1. So I spent 18 years in Kansas City, Missouri, in the surrounds, and was very happy there. And although my family traveled extensively throughout the United States, I found that by the end of the first week away, I was always the child in the back saying, "Can we go home yet?" So travel was not really in the offing that early on. I found it difficult to leave. But when college time came, off I went. I decided to go to the University of Arkansas, and I was part of their honors program there. It was a really interesting experiment to live outside my state, to live in the South for a while. I know it doesn't seem like that big a distance on the map, but to people in Missouri, living in Arkansas is a world away. Well, so after that I moved to, in the middle of college I did some time abroad. I went to Lyon, France, where I tried out my French and could at one point carry on a conversation. Sadly, I've forgotten a little bit in 20 years. And then after that, on the heels of that, I ran off to Chicago, where I spent 6 months as a co-op student, as a programmer, working for a pharmaceuticals company, where I learned how to program in FoxPro. Now, if anyone's heard of that, I would be very impressed. There are a couple. Excellent. Well, after my 4 years at the University of Arkansas, it was time to move on. And again, I tried to make a big push. Now, I've belabored the decision points throughout my career as part of the book that we're handing out in addition to this discussion. So if you want to know a little bit more about the different trials that came along with each of these moves, I think you'll find a lot of information in there that helps tell the story. Although it's easy to look back on my career and say it was all one big series of successes, in fact, there were a lot of tough decisions and a lot of Sturm und Drang, frankly, about moving from one place to another. To give an example, I was living very happily in Seattle at the University of Washington, thus the colors here, when one day my PhD advisor came to the lab and said, "We're moving to San Diego." This was a bit shocking to me because I was in the middle of my PhD program and now I knew I was going to have to move. So to San Diego I went, and then after finishing my PhD in 2003, I spent the rest of my time in Tennessee. there in the southeast. So if we overlay these, we can start up at the top in the middle with two little boys dressed for softball. This is a rite of passage as a young man in Missouri. And I am the smaller one up top there. So this photo dates from 1981. And I want you to think about how that small a child would do if you handed him a book to explain how to use a computer. Because you see, this was the year that my parents first bought a Commodore VIC-20 computer. You could plug it into your TV set. So my first question as a young boy receiving a computer was, where are the video games? Mom and Dad responded, we'll buy them for you when you learn how to write them. That was a big challenge. That was a big challenge. Now my brother took one look at that programming manual and said, I'm done with this. And I grabbed the book from him, and I started teaching myself how to program. So this is what I mean by a very early indoctrination into some of the skills that can show up later on in our careers. Now, I have to say I included the photo at the bottom center just because I love that photo. I graduated from the University of Arkansas in 1996, and that, of course, is Hillary Clinton. So I've been a fan of hers for a very long time, and I have to say that ever since the last national election in the United States, I've been feeling very, very sad. So there we have it. Over at the lower left, we have a picture of a little gray-haired lady. That's my mom. If I had my mama's hair, I would have been completely Snow White by this time. I don't know quite how that gene jumped, but there you have it. And over at the upper right, we have Susanne Mccray, who was my office mate when I was a postdoc. And at the bottom right, we have people from my department. And the first PhD I ever graduated is Susanne Mccray. So these are people who make me feel really happy about all of these times in all of these different places. I have to say that each time I was propelled from one place to another, it was a little like a seed landing in a new yard. And sometimes I sprouted, and sometimes I had lots of productivity, and sometimes not so much. So what do I do for a living? I've tried to answer this a little bit more completely here than perhaps in the abstract, but not tremendously so. I would start by saying that I have been part of the proteomics field since 1996. In a lot of respects, proteomics as a mass spectrometry discipline has only been running since the 1980s or so. And as a result, I've actually been part of the proteomics field for most of its existence. I did not understand how much it would matter which lab I landed in as a seed landing in another field back in 1996. Did I know what a mass spectrometer was when I arrived at graduate school? I did not. So you can imagine that rather big things can emerge from these small chance events that happen along the path. I've drawn in a logo here for CPTAC, and the Clinical Proteomic Tumor Technology Assessment for Cancer is a major program run out of the National Cancer Institute, part of NIH at the United States. And CPTAC has had a huge impact, a very outsized impact on my career. For 10 years, I was part of funding programs flowing from CPTAC. As a result, a lot of the big papers that I was producing were on behalf of a consortium, which gave them a lot more impact and fed them with a lot more data. So being able to assess which parts of proteomics are working well and which are working poorly has certainly been a keystone for me. Certainly, being able to increase the amount of information that comes from biotechnology experiments is something that I've returned to time and time again. In the same way, coming to Stellenbosch has meant that I'm exposed to new technologies that I wasn't previously working with. Because I'm working with a lot of immunologists, I do an awful lot of work now with flow cytometry and Luminex and trying to understand how best to get information out of those data. So along the way, I was one of the co-creators of the ProteoWizard library. That is a very commonplace tool for everyone to use within proteomics. So people who are converting their raw files to MZML format are almost always doing it with software that I was part of creating, and that makes me feel happy. The next thing I would say is that I'm neither fish nor fowl. To the computer scientist, I'm not computery enough. To a biologist, they probably wonder if I've ever held a pipetter in my hand, and the answer is, I have. To the mass spectrometrist, they may ask, well, what was the last time you operated a mass spec? And there, it's true, it's been some time. But by falling in the cracks between all these different fields, I find that I'm often most valuable in a collaboration as a translator, as somebody that the biologist can talk to explain their needs, who can then talk to the statistician and make them understand what kind of model that relates to. So being at this ambassadorial position has actually been very powerful for me. And finally, I know it's a little gauche to say it, but not a lot of professors really love teaching. I love it. I love it. I love being in front of a classroom. I love seeing their eyes open up to say, oh, that's what that means. That is a really exciting part about this job. So, putting me in front of a classroom is not usually something I'm going to say no to. I have to note that down there at the bottom I've included yesterday's count of how many subscribers I have and how many videos I have posted on YouTube. I'm a little manic about it. Every time I'm in front of a classroom, I want to have a camera running so that other people in other places can share and learn in that experience. And I have to say, poor Dr. Beltran, who's co-teaching a class with me at UWC right now, is also getting a camera pointed at her. So soon that class too will be online. What do I do for fun? Well, I think we've already talked a little bit about the singing. I sadly have had to take a bit of a break from Cape Town Chamber Choir. This year has been a little complex. And I haven't quite had the same success in finding a board games group here in Cape Town. So if you live near Everstall and you want to get together to play board games, talk to me. I've discovered that after years of disliking travel, I've finally developed quite a taste for it. And now when I get to travel to new places, it's always kind of exciting. So here I've drawn in a little map showing my most recent flight out to Beijing. Down at the bottom, I decided to show a picture of me with my backpack, my floppy hat, and my camera. Because if I'm traveling, the odds are this is how you're going to find me. I love writing, doing travel writing to describe all these amazing places I've been. So blogging about it on WordPress has been a whole lot of fun. I hope that those of you who read my posts have enjoyed that too. And the picture wouldn't be complete without the most vicious fuzzy cat on earth, Mango. So she helps to pass the hours as well. I've always found it a little difficult how to answer this next question. If I was tenured at Vanderbilt University, one of the top 15 medical universities in the world, why would I leave? Why would I leave that behind? So I would point out that in 2013, I had my first taste of a vestibular migraine. Your ears have nerves in them, and sometimes they can take part in some of the same fun that your brains can subject you to. And if you ever have a migraine that involves your ears, you may find it very difficult to get out of bed. I tried to get out of bed, and I fell. Working at a medical school is not a particularly conducive environment for having a medical condition that causes you to fall over. So being stressed all of the time and always feeling responsible for firing off yet another grant that month is something that can have rather pernicious effects on your long-term health. For me, developing vestibular migraines was the bridge too far. By the time I had a diagnosis for it in 2015, I already knew it was time for me to restructure the way that my career was going to work from this point forward. Now, you might ask, how would reducing my stress be compatible with the idea of moving a third of the way around the world? And you would be right to ask that question. And my parents back in Missouri ask me on a regular basis, wasn't this intended to reduce your stress? And what I always tell them is, yes, I'm busier than I was when I lived at Vanderbilt. Visiting 3 campuses every week is certainly something that keeps me a little confused and a little bewildered all the time. But the reality is, I feel better after each week, even though I'm busier. By being at all these different places, doing things I believe in, my career has become much more emotionally satisfying to me. So it has all been worth it. Now I have, Gerhard, I believe you've said I need to be more careful about citing my funding agency. Is that correct? here we have the South African Medical Research Council. My first visit to this campus was in 2014. I came because Gerard Trump out there had won the job I'd applied for. But I like these guys, and they liked me. So we sat down over at the Cups and Saucers, and we talked about, could I come here on a 2-year contract? And I answered, no. I said no. And that hurt, because I like these people. But because the Medical Research Council saw promise in seeing more education for bioinformatics researchers here at Stellenbosch University, they agreed to kick in 3 years of a 5-year contract. So I owe them a lot. South African Medical Research Council paved the way for me to show up here, and to show up at CPGR, and to show up at UCT, and to show up at UWC. They're the reason that I can be all of these places and reach all of these students. And that is pretty darn exciting for me. So let's try to answer the question, how does South Africa solve the problem of not having enough bioinformaticists and not having enough statisticians? We're going to start with laying the groundwork early. Not enough children in South Africa have early access to computers in any way that would be conducive to them learning to code. Learning to code is a really critical skill. And of all the people in this room who touch a computer every day, the number of you who learn to write programs for it, even a little Visual Basic macro in Excel, is actually vanishingly small. So encouraging kids to code at as early a point as possible matters. Now, you might think, well, what child is ready to sit down with a C++ manual? And you would be absolutely right. But I would point out that projects like Scratch over at MIT have made programming accessible to a lot of people. So if you look over at the lower left, the big bracket around everything says, when clicked, set the counter equal to 1, and then repeat 12 times, say counter for 2 seconds, change the counter by 1, and then end the loop and stop the script. I think most of us who've had any exposure whatsoever to programming would recognize this as a for loop. And teaching students things like how to iterate through the same block of code, changing a variable by 1 at every cycle, is a very valuable part of learning to program. And if kids are learning this as a way to make the Smurf move 12 steps across the screen, that doesn't diminish the fact that they've learned something about iteration. So this code is available for free to anyone to use. And this language can make something much more accessible to people who might otherwise have very little exposure to programming. Of course, a lot of people make the joke about there's an app for that if a random thing that you could apply your cell phone could be applied for. That there's some way to make your phone do almost any conceivable activity. But I'd also say that app creation has been a kind of exciting place to get young people engaged in programming. And to do that with teenagers is, I think, completely appropriate. The next thing I want to talk about is a birds of a feather activity for secondary schoolers. Specifically, I think it's really valuable to have things like nerd camps. It's a despicable term for something that's actually quite pleasant. Your child, if you have a child, if he's interested or she is interested in the sciences, imagine how stimulating it is to spend that time in the company of other people who feel the same way in the same age cohort. These matter. And competitive sciences, competitive mathematics, these matter as well. You don't have to be on the chess team to be in competition in academia. Finally, I want to say it's very important that we are able to recognize and celebrate talent. And for this, I think having government programs and media programs that are focused on highlighting kids who are special is necessary. And finally, I just want to point to this little photo at the lower right. For those of us who grew up with Legos a very long time ago, you might not even realize that Legos have grown up a lot, and there's an awful lot of technical sophistication that you can get with your construction kits. So These are not to be denied. These are very important. So I've picked a set of photos here that each have some emblematic touch to that slide for me. At the upper right, we have a capsella play kit. Each of those little blobs can be put together into little drivetrains and things like that, attached to wheels, to propellers, to floats, to all kinds of things, to build boats or to build cars. I love these things. Somebody even built a capsella add-on that would let you connect your Commodore 64 to this playset. And if I'd had that, I can't imagine what kind of stuff I would have done in robotics. Now, at the left, we see a computer interface, and this might look a little unfamiliar to you if the only thing you've ever seen is Windows or Mac operating systems. That is the user interface of a Commodore VIC-20. And if you see, it announces to you how much space you have left. 3,583 bytes. When I was in elementary school, I thought to myself, I could never write a program that big. And now I have software that takes gigabytes of RAM all at once. It's unimaginable to me that we have this wealth of space to work within today. So if I could learn something useful about programming on a computer with a 1 megahertz processor, not a 1 gigahertz or 3 gigahertz processor, imagine how much more powerful an experience kids of today can have. Down the middle, I've included logos for 3 different camps or competitions that matter to me. The top one is Missouri Scholars Academy. Each high school could nominate kids to be part of the Missouri Scholars Academy after we turned 16, summer after our turning 16. So Missouri Scholars Academy was incredibly exciting. I was kind of terrified at first. I thought, I'm used to doing well at my school, but what's going to happen if I'm in a pool with a bunch of smart kids? Well, I'm not going to be the big fish anymore, will I? And that was daunting. It really scared me because I was fiercely competitive. But Missouri Scholars Academy turned out to be very much a birds of a feather experience. And it taught me that we can excel together. If we drop down from there, we get to something that's a little more carnivorous, perhaps. Science Olympiad. This is a competition, a whole series of competitions in 20-some different things, like could you build a better parachute for an egg from pieces of paper, the egg drop competition. But my favorite event was Science Bowl. Who could buzz in most quickly with the answer? Who could nail the other team to the wall? Oh, I loved it. Fiercely loved it. We made it to state, and I was so thrilled to be in that event. And finally, the United States Presidential Scholars Program. One of the things that I feel I must point out is that being part of a Missouri Scholars Academy, being part of the math team or the science team, that these events taken together add up progressively to a more and more impressive resume for children who are approaching matric. And at the end of the day, they can apply for scholarship programs on the strength of having won all these other things. Gerhard, I think you would agree this is very much like the grant scheme. If you win this grant, you can probably leverage that to win the next one, right? Teaching our kids that successes can lead to successes is a valuable exercise. Now, the other person I want to point out here is Phil Witt. He's down at the bottom right of the screen. Phil Witt was the NBC news anchor in Kansas City for many, many years. I forget how many decades he'd served as a news anchor at the time he retired. But at the time that I was a senior in high school, he was running a program where he would feature a high school student every week who was excelling in local high schools. And my school put me forward for it. So I got to meet Phil Witt. Here was my chance to meet celebrity and see I could be part of that world. I think celebrating talent is something that we must do. It's sometimes the case that people enter biology rather than chemistry or physics or mathematics because they hear it involves less math. Would anyone admit that in this room? No one would admit that. A few people would admit that in this room. That is okay. People get told these things. All biologists need numeracy. Numeracy. Why am I using the term numeracy? Well, literacy has been taken up for all the words and things, but Put the words aside, and let's think about the data. Where we have the data, we need to be numerate. We need to have the understanding of statistics to understand the distributions from which these come. We need to be able to understand what it means to generate 1,000 p-values and say, well, a bunch of these are probably less than 0.05 by chance. So numeracy matters. So I'm going to give you 4 examples of questions that play into this. Which proteins did we identify? That, more than anything, has enlivened my collaborations with biologists over the years. What did we identify? So for that, we require a whole slate of bioinformatics algorithms. Which of these differences are real? Did Taryn Young make it here today? Ah, brilliant, there you are. Good, good, good. We need biostatistics for this. And biostatistics literacy really, really matters. Finding a way to prioritize everyone getting a good exposure to statistics is essential. So maybe I just got some data back from CPGR. Somebody handed me a FASTQ file from my experiment. So now what? How can I tell whether this FASTQ file is actually legit, has decent reads within it? For this, you're probably going to need to know something about quality control. That too falls within numeracy. And a question that I think is hugely important for everyone to be scientifically literate is, can I believe the claims in this paper? Because all too frequently, scientists are pulling a fast one and not even realizing it with their publications. So being critical readers of methods sections and understanding whether or not this holds up to scrutiny matters. All biologists need numeracy. And I want to quote my undergraduate mentor, Doug Rhodes, who said, if you stay in biology, nobody will ever object to your programming. I could stay a biology major and program away to my heart's content, and that was all going to be just fine. So I love that advice. Now the other part of this was that at the time, back in the 1990s, remember, he told me that if I changed my major to computer science, my biology days were over. So biology is actually quite an ecumenical field in allowing people with a very broad set of skills to come together. That is a strength, not a weakness. Now, I ask you to look at this picture of 6 luminaries. I'm going to include myself, just pardon that. 6 people, let's say, who have contributed to the proteome informatics community. All right, now which of these people is trained at the PhD level as a bioinformatician? All of them? None of them? One of them? I'll just note that out of all of these, only the fellow from Portugal got a proper degree that includes bioinformatics. I came from a molecular biotechnology program. Alexei Nasbishti graduated with a degree in physics. The fellow from Portugal there is Nuno Bandeira. He's an amazing researcher. He has his training in both computer science and bioinformatics. Parag Malik, up at the top, is a co-creator of the ProteoWizard project. His degree is chemistry and biochemistry. And I will just add as a side note, he's also an excellent magician. You should always get the chance to see his show. Leonard Martins, I know, has come down here a few times. He trained his degree is in biotechnology, much as mine is. And the guy down at the bottom, Jimmy Eng, is an electrical engineer. Wrote one of the most seminal algorithms of proteome informatics, the sequest algorithm. As I start closing in on the end here, I want to note that a bioinformaticist cannot sit in an ivory tower. There are a lot of people who think that computer people, we should put them all in their own department and hopefully they won't bother us too much, right? That is a dangerous thing to do to a bioinformatician. What this creates is an atmosphere where the bioinformatician is unaware of how the field is changing that he or she is trying to create tools for. That's very dangerous. Instead, you want to have the bioinformatician engaged with the application area. That's how the person will know what the good problems are that require attention. Bioinformatics people are often incremental research of tweaking a system that's been published in the past to say, lo, we now get 10% more good results. That is not a very good thing for a scientist to spend time doing. We really need to think innovatively. We need to be able to create new tools that are highly novel. There is also a very unfortunate tendency in bioinformaticians to be opaque, to be unwilling to explain how those black boxes work. You just do this to your code and out pops this table, and don't you ever ask me a question about where those values came from. That is very dangerous. We all must work towards open science, being able to encourage equal partnerships where the bioinformaticist is learning from the biochemist and vice versa. Certainly, we also run into the problem of being unable to explain the value of our tool if we don't know the field well in which it's operating. Being relevant, being clear about the statements of significance is something that we all must work toward. So being separate from your bioinformaticist, having the math people all together and everyone else safe on the other side of a moat is not a good, it's not a viable business model. I would point to Vicki Wysocki, who is a very, very eminent analytical chemist, as the person who dragged me, kicking and screaming, into the world of analytical chemistry. She wasn't even at my institution. I was at the University of Washington. She was a professor at University of University of Arizona, pardon me, Vicki. And she made the time to fly me over to the University of Arizona to tweak a mass analyzer using an oscilloscope. This is not the sort of thing most bioinformaticists get to do. I was drawing a chemical bond on the chalkboard one day and trying to explain this difference in which amino acid was where would lead to a change in fragmentation. And she took me up on it. She said, okay, draw the electrons on that carbonyl. Show me where they go in this reaction. That was very challenging for a wannabe computer scientist. Being a not very good chemist and a not very good computer scientist is not really the best place. Sometimes it involves learning skills in both of these realms. And Vicki was certainly somebody who pushed hard to see that I knew something about the field I was part of. Now, soft skills are something that we don't frequently celebrate here, but I have to say that soft skills were a huge deficiency for me. I was stubborn. I was competitive. I was aggressive. And if somebody challenged me, I was often trying to look for the flaw in their argument rather than asking whether there was some basis to this. This has been a tough grist for the mill, and a lot of mentors have made a huge difference in shaping me. Now, I really do hope that you will pick up the booklets that we put together, the little biography that I put together, because I really try to talk through all these different people who intervened to save me from myself in a great many conditions. I would particularly like to highlight Susanne Mccray. She's now a dean herself over one of the schools, but at the time, she was the honors program coordinator at the University of Arkansas, and she took this rather brittle young man who really couldn't deal very well with being outside his native Missouri and helped to soften some of the edges for him. So Susanne made a very big difference, and she had to listen to an absurd level of nonsense, I must say. She was a real mentor to me. Below, I've highlighted Laurence Florent and Mike Washburn. They're a married couple, and they're an astonishing pair, actually. My PhD advisor had never had a PhD student before me. I was his first to come in as his very own student. And I have to say, it was a learning experience for the both of us. So I would say that in some respects, Mike and Laurence took aside this kind of struggling graduate student and said to him, you know, this work you've been doing on software, the software's really great, but you should write the paper about that. I needed to hear that. I needed to hear that I'd done something worth publishing, because I don't think that students show up at our programs with an inherent knowledge of just how much work that very first paper takes. They made a big difference. And Dan Liebler, who recruited me to Vanderbilt University and included me in an awful lot of grant opportunities from the word go, is certainly an important mentor. He shaped a lot of my career. And I would note that the fact that he was leaving Vanderbilt University had a lot to do with the fact that I decided, well, it must be time for me to go too. So in some ways, that made me open to the opportunity that was here. I think Natasha would feel deeply embarrassed if I were to say everything I'm feeling about her, but for those of you who don't know, 2 days from now, I get to hold her hand in front of her family and tell her we're going to be together for our whole lives. We're getting married on Thursday. And my life in Cape Town would be in no way the beautiful thing that it is if it weren't for her. So, thank you, Natasha. And with that, I would call this lecture to a close.